how we multiply in powers with the same base. If you look, we have 2 to the 4th power times 2 to the 5th power. Our base is the 2, right? This base is 2 to the 4th power. So we have how many 2's? 4, right? So let's write that. We have 2 times 2 times 2 times 2. That is 2 to the 4th power, right? And then it says multiply that 2 to the 4th power by 2 raised to the 5th power. That is 5 2's multiplied by themselves. So let's do that. 1, 2, 3, 4, 5. Well, if they're not asking me really for an answer, they want to know, multiplying powers with the base. So we're going to kind of evaluate it only. So the answer is, what is asking me, how many 2's I have, right? What is going to be the true exponent? Well, I have 2, which is the base, which is the same. And how many of them do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So the answer for here is 2 raised to the 9th power. Then if you were to put that in your calculator, or if you really want to get creative and do it by hand, you will put in your calculator 2. So we have 2. And you remember when we've talked about the y to the x is really what is the exponent, right? So if I was to hit that, now it's asking me, okay, what is the exponent? Well, the exponent is 9. So 2 raised to the 9th power is 512. Let's look at the next example. We have 5, negative 5, base for here. And the base over here is negative 5 as well. However, the exponent is to the 6th power. Well, what is the exponent in here? If the exponent tells us how many 5 multiplies themselves by themselves, in here it's going to be 6 5's, right? 6 negative 5's. In here we just have a 1 negative 5. So really, truly, there is an exponent, and the exponent is 1, right? Because there's only 1 negative 5. So let's look at the first one. We have only 1 negative 5, which is multiplied by negative 5 raised to the 6th power. So I have 6 negative 5's, right? So let's do that. I have 1, 2, 3, 4, 5, 6. Well, how many negative 5's do I have? 1, 2, 3, 4, 5, 6, 7 negative 5's. So I have negative 5, and I'm putting in the parentheses, raised to the 7th power, right? So how many negative 5's I have? 7 of them. And let's look at one more example. And yes, there's variables, but it means exactly the same thing. We have base is x. Here is base also an x. How many x we have in here? 3 of them, right? So we go 1, 2, 3 times 7 of them, right? 1, 2, 3, 4, 5, 6, 7. How many x do I have that multiply themselves by themselves? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. So the answer is x raised to the 10th power. Not sure if you guys caught on to something. This is how we will do it if we were to go the long way. Now, if you noticed something, there is a shortcut. How many 2's I have in here? 4. How many 2's I have in there multiplying themselves? 5. So why not just simply do 2 is my base, right? There's the same. One exponent is 4. We have 4 of them. The exponent says we have 5 of them. So why not add them, right? 4 plus 5 is 9. In here, I have negative 5, right? is the base for both. How many negative 5s I have in here? We said there is one. Let's don't forget that one, right? And in here we have 6. So 1 plus 6, we have negative 5 raised to the 7th power. Same in here. The base for both of them is the same, is x. We have 3 of them in here and 7 of them in there. So the answer is x to the 10th power. Let's look a little deeper. This is power of a power. What does that mean? Well, if you look, we have an exponent, which is the power over here, and then we have another power, another exponent over there. Let's kind of look at it. What are they telling me? If I look only on the inside, well, how many 3's do I have that are multiplying themselves by themselves? 4 of them, right? Let me kind of highlight it maybe. That may help a little better. So this in here is telling me I have 3 raised to the 4th power. That is, write that 3 to the 4th power 4 times. Now each 3 to the 4th power also is written out 3 more times, right? So I have 3 to the 4th power in here. So I have how many 3's? 4 of them, right? 1, 2, 3, 4. That's great. However, this thing in here says raise it to the 3rd power still. That right now they're telling me I have this thing in here written 3 times, right? So I will have to go. This is 1 time. Two times, and how many they said? 3 times, right? 3 is my power. Well, how many 3's do I really have? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My answer is 3 to the 12th power. Well, is there any pattern you have noticed? I'm sure you have. In here, it says 3 to the 4th power, right? We have 1, 2, 3, 4. How many times? I'm telling you that right there. How many times is the 3 to the 4th power raised? 3 times. Are you noticing what's going on? 3, right? Written by themselves 3 times. 4 3's written 3 times. How about if we were to multiply it? 3 to the 4th power raised 3 times, times 3, which equals 3. And what is 4 times 3? 12. Aha! There it is. There's a rule to it. If you guys will not remember this, please make sure you may want to write them all out. There's no shame in that game. Go ahead and knock yourself out. The next problem is I have w raised to the 5th power, and how many times do I have that w raised to the 5th power? 4 times. So if you noticed, you will do w to the 5th power, and how many times? 4 times. So my answer is w, whoopsie, 2 raised to the 20th power, right? If you don't believe me, then write it out. You will have w to the 5th power. So how many w's do we have? 5 of them. 1, 2, 3, 4, 5, right? And the 5 w's are written 4 times, right? So that means I would have to write this how many times? 4 times. So if you were to actually do that, 1, 2, 3, 4, 5, that's 2. 1, 2, 3, 4, 5, that's 3. 1, 2, 3, 4, 5. How many w's do I have? 5, 10, 15, 20. W raised to the 20th power. I think this is much quicker, isn't it? Let's see, is there anything else? Oh, same thing in here, but little different. Pay attention. If I have a parentheses, do you remember distributive property? In distributive property, we had, let's say, 2, and in parentheses, we will have 2 plus x, for instance. We knew that 2 in front of the parentheses will multiply that 2 as well as the x. Similar thing applies for exponents when it comes to powers. So finding powers of a product. Product means multiply, right? So there's a multiplication between the 2 and the x. And if you look, there's an exponent. The exponent is applying to the 2 as well as to the x. So really what I have is 2 raised to the 3rd power times x raised to the 3rd power. What is 2 to the 3rd power? Well, that is 2 times 2 times 2. 2 times 2 is 4 times 2, which equals 8. So I have 8 times x to the 3rd power, and there is my answer. Sounds good?